Okay, number 8 asks, convert the structure in line notation into the correct Fischer projection. So Fischer projections can be a little bit tedious to deal with and hard to visualize, but what we have to understand is that we can think of these as little bow ties where all of the horizontal bonds are wedge bonds. It is the case that all of these groups going horizontally are being pulled towards us. And so what that means for line notation is that we have to orient it in a way such that the two substituents going either way from the main chain have to be pointed up towards us. The hydroxyl and the chlorine look good, but we do actually have to rotate these bonds to put the fluorine up over there. And so we're going to get a situation like this, where that hydroxyl is going to stay on the wedge. And now this fluorine got flipped up. And so because it was on the wedge, it's now going to be on the dash. So we have a fluorine there. And then that chlorine stays as it was. When we're looking at a Fischer projection, think of yourself right here. And it's like we're going to snake along the molecule. We're kind of pulling the molecule as we go and looking down on the two substituents that are pointing up towards us. So this is the correct orientation. If we want to convert something in line notation to a Fischer projection, this is the way we have to be visualizing it. So as we travel along this carbon chain in this direction, what are we seeing? We see the OH up and to the right, and then we see the fluorine up and to the left, and then we see the chlorine up and to the left. We need the hydroxyl on the right, the fluorine on the left, and the chlorine on the left. And then we have methyl at the top and methyl at the bottom. And so which one of these gives us what we just said? We need the hydroxyl on the right, then we need the fluorine on the left and the chlorine on the left. So that looks like it's going to be option A. These can genuinely be very confusing, but this is the way you want to visualize it. You need to have the carbon chain arcing along like that, and all of the substituents pointing up towards you, because that is what Fischer projections represent. All of the horizontal bonds are wedge bonds, so all of those horizontal substituents are pointing up towards you. So we do have to sort of travel along the backbone this way with all of the substituents pointing up, and in order to get that, we sometimes have to rotate some of these carbon-carbon bonds in order to get the substituents pointing down to be pointing up instead. So as long as you can visualize it that way, everything will be good.